Thanks, Matthias. And hello, everyone. And today, I'm going to be talking about container security with Falco. Although Matthias introduced me really well, thank you so much. But I also decided to introduce me. I'm Ayesha, and as Matthias mentioned, I'm working as a site reliability engineer at Ambition. It's a startup from Mercedes-Benz. And I'm very passionate about containers, cloud security, and other cutting-edge technologies. I really enjoy working with Kubernetes, open source tools and technologies, and also with the cloud. It's my first time in Switzerland, and I'm really excited about it. It's a beautiful country. I live in Germany, Berlin, but originally I'm from Pakistan, but living in Berlin for the last 4 years, which is great. So let's jump into Falco. I would like to talk about very basic, like what is Falco? Falco is a cloud-native runtime security tool for Linux operating systems or for your containerized environments. As the containerized applications and the usage of Kubernetes have been grown, the security issues and concerns also have been arises. And this Kubernetes security is itself a challenge. And to overcome that challenge, SysDick developed a tool called Falco. You can think of it as a camera for your running applications on your Kubernetes clusters. And Falco, basically what it does, it listens your system calls or the system events generated by the processes running inside of your kernel and detects those events and any suspicious activities, any abnormal behavior of your system, whether it's suspicious network activity, sensitive file accesses, or any suspicious processes running in your Linux kernel or on your system. Falco knows everything. As Falco runs at the kernel level, which makes it a very powerful security tool, because whatever is happening in your system, your kernel knows everything, right? I mean, you are running your application in your containers, but whatever the traffic is coming and going, any file access is happening, it generates the system calls. And Falco works at that system calls level, which makes it a very powerful runtime security tool. Falco originally created by SysDick, but now it's a CNCF graduated project, and many, many big organizations are using that project. So I would also like to talk a bit about the architecture of Falco. So as I mentioned, Falco listens the system calls that have basically generated by the processes running in your system, but they are not the only sources of they are not the only event sources for Falco. There are other event sources that Falco can basically detect events from, listens events from, and basically alerts you for any suspicious behavior or any security vulnerabilities activities. For example, Kubernetes audit logs. Falco can listen all of the requests going to the API server and detects any abnormal behavior. For example, any privileged pods creation, any escalated privileged service accounts, so this kind of stuff. Falco can knows like everything related to Kubernetes audit logs, and there are many other event sources which I'm going to be talking in detail in next coming slides. So for now, Falco basically primarily focuses on the containerized Kubernetes security, and it uses kernel module or either eBPF technology to listen those system calls in your kernel, and basically okay, I'm audible. So it uses kernel modules or either eBPF technologies to listen those system calls and stream those events at the user space. Just to recap, that eBPF is an extended Berkeley packet filter. It's a technology that allows you to run sandbox programs into the Linux kernel in a portable way. So eBPF basically allows you to attach your programs with the Linux system calls or system events, where it can basically perform the actions you want to do, so you don't need to have to load the kernel modules or something. So in an environment like containerization and the Kubernetes environments is the best way to do it. It makes Falco really powerful tool. So here, either you can choose like kernel module or eBPF, modern eBPF, and it listens the system calls and generated by the processes in the Linux kernel, and stream those events to the user space where Falco engine is running. And Falco basically filters those events against the Falco rules that you have defined and detects the vulnerabilities or the abnormal behaviors or any security threats and alerts you on the basis of that. And these alerts, the output can be in many ways, in any kind of output, like file output, standard output, shell, HTTP, and Falco sidekick, which I'm gonna also be talking about in coming few slides. So that's the basic architecture, how Falco works. So yeah, about event sources, as I mentioned, Falco tracks system-level activities, for example, file accesses, networks, processes via kernel module or eBPF. Falco can also gather data from container environments, for example, Docker, Cryo, Containerd for context-aware monitoring. It can monitor Kubernetes API requests to detect unauthorized and suspicious events and actions. And it can also basically monitors the cloud activities logs, for example, AWS CloudTrail, GCP audit logs to detect potential security incidents. And definitely it also gives you, allow you for integrate other event sources through Falco plugins. And there's a documentation that is available that how you can use Falco plugins to integrate other event sources according to your use cases and your requirements and needs. So I have talked briefly about Falco rules. Falco rules are basically really important thing for the Falco because these are the policies and these are the rules on the basis of you can define which events or which activities are the secure ones or which are the abnormal behavior or abnormal file accesses and all of that stuff. So these are the policies you define for your security, for your security of your application. So, but Falco basically comes with extensive default set of rules and policies that you can definitely deactivate them if you want to and just use them as its default. And these default rules basically covers many aspects of your application. For example, host security, it can detect any unauthorized access, privilege escalations, and system tampering in your cluster or in your host. And container security, it can monitor container behavior such as privilege changes or unexpected network activities. It can definitely cover the topics related to the container security and also identify the cloud anomalies in cloud provider configurations, for example, IAM roles and security groups. So, and there are many default set of rules for Falco that you can use them. If you want, you can also deactivate them if you don't need some of the rules or can make changes into that as well. And you can definitely write your own customized policies or rules for Falco according to the needs for your system and for your requirements. And it's also very like, but writing those rules, they are very, in a YAML-based files, you can write the rules in a YAML files. And it's quite easy to write, but you have to know that what you are writing, because Falco condition, for example, that's an example of a rule. Detect bash in a container. So that's a rule where I am I'm writing a rule that if there's a bash in a running container, I should get alerted, right? And priority is info. So, I mean, you can have different priority set according to the rule, like warning or info or anything, but here is info. I mean, it's just a bash running in a container, and you have to set the description. Basically, you should not have a shell running in a container, and then you set up the condition. And the condition is container.id should not equal to host, so means that the container, the process should be running in the container, not on the host, and the process.name is bash. So here, process.name bash. So here, when you're writing your conditions, you should have understanding of a knowledge for the system calls, where you're going to be setting your condition, and then you have basically defined the output that how you should get the alerted and how your output should be, what information you need in your output. For example, username, exact command line that you have used, and the container info. And when the rule got trigger, that should be in the down picture, there is that should be your alert whenever this rule gonna be triggering. But definitely it would be great like if you have understanding for the writing your own conditions. And Falco have like different ways of writing those conditions. You can create lists, you can create macros to basically reusability of your code and reusability of your YAML-based rules. So yeah, you can get definitely a lot help when you're writing your own Falco rules. I would also like to talk briefly about the standard output. As I mentioned, that the Falco can send those alerts or give you the output in any way that you want and that you required. For example, it can definitely logs alert directly to your console or the Kubernetes logs like standard output, or it can write alerts to a log file for persistent storage. Syslog, it can send alerts to the systems logging facility. It can definitely send alerts via HTTP post request to a specified endpoint, and also can use gRPC, transmit alerts using gRPC protocol, allowing for efficient and scalable communication through your microservices. And either you use Falco Sidekick to forward your, Falco Sidekick. So Falco Sidekick is a companion project for Falco. And this project is basically extends the capability of Falco alerting. Falco Sidekick is a project where basically helps you to forward those alerts, those security alerts, to any external systems or services that you are using. It can be anything, like it can be your chatting system, for example, Mattermost or Slack, or any alert manager, for example, PagerDuty, Opsgenie, and Elasticsearch, Datadog, Dynasty. So the list is huge, and on the documentation, you have a very detailed documentation where you can decide you can see that how you need to configure those integrations with your specified tool or whatever you are using. And it's actually really, really helpful, especially when your company, you're using, for example, Datadog, and you don't need to go to any extended another platform, or you don't need to always look at logs to get the alerts. You can definitely get those alerts on Datadog or on Slack. So list is huge for the extending. But Falco Sidekick also provides a UI where you can, it's a great UI where you can visualize all the alerts and everything at one place. It's a user-friendly interface, real-time event monitoring, and you have an integration support with Elasticsearch or any external tool or platform, and centralized dashboard. And just because you get those alerts in a real time, and you also have the option basically to react quickly and solve the issues more proactively. So there are many advantages of Falco, that it's open source, CNCF project, it's a strong kernel-based monitoring, it has many event sources, Linux system calls, Kubernetes audit logs, cloud activities logs, it has a great alert output, and you have customized policies, you can customize your own policies, but only disadvantage is that Falco is primarily an alerting tool. It does not prevent action to be happening. You have to take your own actions to block those security vulnerabilities, or set up the mechanisms to prevent it in the future. So it's basically an alerting tool and doesn't provide any preventive mechanisms. So I would also like to show a basic demo how Falco works. No, it's okay. Yeah. So I would like to talk about, I would like to give a basic demo that how Falco works and how you can install in your Kubernetes cluster. So here I have basically used Kind to install the cluster for this demo. and I can install Falco. Yeah, I can install a Helm chart of Falco, and this will simply installing the Falco in your cluster. Just to make sure that it's visible good. So yeah, it will take a little bit of time to install Falco. And you can see that it basically installs in the form of the daemon set on each of your node, so that each of your node is like protected. But also it's recommended to install Falco on your host machine. In case, for example, Kubernetes is compromised, your Falco is already running, and you get the alerts, and you know that what happened and what's happening. So, but I mean, you can also install it on your Kubernetes cluster and on different host machines. It takes a bit of time. Okay, so our pods are running. I would like to talk about little more about these config maps, where you basically have the all of the information related to the Falco and configurations of the Falco, for example. Okay. Yes. So you can see that's a config map. So basically, through those config maps, Falco integrates all of its configurations and all of its rules and everything in the pods that are running. For example, here I would like to just briefly talk about, for example, in this config map, you can see engine, eBPF, it's using eBPF, modern eBPF, and all of these information related to its configuration. I'm not going into very deep detail into that, but I would like to show one thing, which is rules, Falco rules files. And these rules files, these are basically the path in the pod's root file system, where those Falco rules have been like residing. Let's just look into that Falco rules file. Yeah, so that's a big rules, Falco policies and Falco rules file, where you have so many rules. Find AWS credentials. For example, this is a rule, and there's a description. There's a detect an attempt to search for private keys or passwords using the grep or find command. And for example, if this is a rule, right, and this rule, if someone is trying to do that, you're going to get the alert. And for example, if you see the condition, there is like spawn process, and it's a kind of a list that have been used here, and grep commands and process.name find or process.argument ends with. So I'm not like going into detail for all the rules and all of the system calls that have been used here, but that's a rule file that comes with Falco by default, and that you can basically look at it and decide that maybe some of the rules you don't want to get alerted for. But that's a rule file that you can look at. For example, one of the rule which I wanted to trigger, which is untrusted, reading sensitive untrusted file. Okay, so that's the rule. Read sensitive file untrusted. So basically, what this rule says that if you have any sensitive file in your container and any user is trying to attempt to read any sensitive file, you should get alerted, and the alert should be triggering, right? So how it's gonna be working? It's a very like a basic simple rule which I want to trigger, and just to see that how it works. So for that, what I'm gonna be doing, I'm gonna be deploying a simple deployment, Nginx server maybe. So one moment. In a different namespace, kubectl. Okay, so that's a deployment that I have created. And our pod is running. So what I will be doing, I will be, for example, it's an Nginx file, and I will be trying to read a sensitive file, which is /etc/shadow, where you have some sensitive information related to Nginx. Yeah, so this is a file, and you can see that it's some sensitive information in the running pod. So let's just see if the pods have actually detected this activity happened. I mean, it didn't stop, but you can get the alert. Okay, so log files were tampered, and there was like, I mean, we are looking at the logs, so that's why it's showing log files are tampered, and the sensitive files opened for reading by non-trusted program /etc/shadow, and you get a kind of a warning, and you can see in the logs, right? So I would like to also create my own custom rule, which I've already written here. Everyone can see that, right? So it's a custom Falco rule, and this rule says that right below in the etc directory. So for example, if there's an attempt by any user to write in the etc directory, then you should get the alert. And that's a description, an attempt to write to /etc directory condition, where I'm saying that the event type is in, like it's like a list in open, open@, open2, and event is open write is equal to true, and this is a condition that I have created, and I would like to receive the output in that particular format, where I'm like trying to get the output of the user ID, username, except the process name that was run, and the priority, and the tags. Basically, tags we use to categorize those alerts. When I show you the Falco sidekick, I will also explain it more, just to you can filter those on the basis of the categories, those alerts. So let's just upgrade Falco with those custom rules. So what I'm doing here, if I am trying to write in the etc directory of the running pod, this rule should be triggered. And that's my customized rule that I have written, and that's, I mean, YAML-based file, so it's easier to write. Okay. So yeah, that's I tried to write in the /etc directory, and I'm gonna get the, the pods have restarted, so my speed gets actually quite slow due to this mic is not working. Thank you for your patience. Okay. Okay, so that's file below /etc open for writing, and you see that this, yeah. So this is the file that I tried to write, and you get the alert, right? So these are the very basic policies that I try to trigger, but these policies and these rules can be very helpful when it comes to any critical situations or critical security vulnerabilities according to your use cases. But let's just get done with this black screen. Let's look at the Falco sidekick UI, which may be a little colorful for this, for this black screen. So yeah, that's a trigger, but I would like to upgrade Falco with the Falco sidekick UI. Here I'm using Helm chart and installing it via Helm, but you have if you install it with the Helm values.yaml, you have directly upgraded all of the things according to your needs. So yeah. Okay. So now the new pods and the services for Falco sidekick UI started running. Just give it some time. Okay, so now it's running, but it's not ready. Port forwarding the Falco sidekick UI, and yes. Initially, it was already login, so it's admin. You will have a login screen where you can set up admin as a username and passwords. So that's the Falco sidekick UI. There are not events yet, but let's just trigger the same rules that we have triggered earlier and see if we get those alerts or not. For example, creating a random file or trying to access the sensitive file. So let's see if you get, yeah. So here, you see there are some changes and some alerts and some events. As the kind cluster I've installed, so there is a one control plane and one worker node, so it's showing that's why 2 times. But you have like, okay, it's not needed to be that much zoom. Okay, so here you can see the warnings are in the, you get the real-time warnings, read sensitive file untrusted, and all of these kind of things. You can basically filter the priority, filter the host names, filter the rules that you want to get, and these are the tags that you can filter on the basis of that. And you have the dashboard that what rules have triggered and what things have triggered. And that's like a great overview and visualization of your security of your containerized and your running application, or either with your host machines. And I would say that's a quite basic visualization or a demo that I have given, that what you can achieve with Falco. And you can definitely do much more than that. So as the conclusion, that I believe Falco is a great tool for the security and for the container runtime security. It does not prevent actions to be happen. Maybe there are some other alternative tools that are doing that. There are always pros and cons of any security runtime tool. I'm not one of the creator of Falco, but I use it and I enjoy working with it. So yeah, thank you so much. And just this is my LinkedIn QR code. Please just connect. And thank you so much for your patience and listening to talk. I hope I didn't bore you. Thank you. If you have any questions, please.
Thank you very much, Ayesha, for this insightful talk. Do we have questions? Mattu? I'll do my best.
Hello. So first of all, thanks a lot for your interesting talk and for the absolutely brilliant live demo with one hand. So I guess that's an applause of its own. So what interests me is exception handling. So how you're gonna manage exceptions. So if you have like workload that create alerts in a normal environment, but that you have to configure like exceptions for some of your pods or some of your deployments. How do you handle that in your environment?
Okay, I mean, maybe I didn't understand your question. Like, maybe you explain it a little more. Like in the environments, what kind of exceptions comes in your mind?
If alerts are default, so alerting like reading etc files is the default. So if you have just one pod or one environment, one namespace where it is allowed to actually read the etc files or write to the etc files, just in one case, and all the other 99% of the cases you want to have the alert, but just in one case you say for this workload it's okay. Mm-hmm. So can you kind of handle these kind of exceptions, or how do you configure these?
I believe definitely you can handle it. I didn't try it by myself, but you can definitely handle that. You can definitely make changes. Maybe you have to make changes in those rules that have already defined. And you have to basically define that maybe the container ID should be like that, or maybe the container.tag should not be equal to that. So you can make changes, right? There are default rules. Maybe you can make changes disable them and write your own customized rules. And in that customized rules, you have the more flexibility to make changes in that particular rule and write your own rule itself. So yeah, that maybe definitely help you. Mm-hmm. On your back. Okay, front.
Thank you again for the talk. With tools like these, a big question is always like, what kind of overhead or performance impact can we expect on a cluster? Like, especially with like a big cluster, lots of workloads, lots of events coming out. Like, how well does the rules engine deal with that and stuff like that? Did you ever see that in a really big cluster with lots of events?
Yes, I mean, Falco have been using in many big organizations where they have big workload is running on their clusters, and making it at the kernel level and using eBPF, which is itself is a lightweight technology. When you are loading kernel modules, it's more heavier and more like overhead, but eBPF make it enables you to do it in a very portable manner, and definitely it's deploying at the form of the daemon set, so it's deploying on each node and detects and listens those events and system calls, and everything doing it at the kernel level and at the system calls level, and alerts you in a real time. So I think Falco is powerful, and it can definitely be a great security runtime tool, even with the huge workloads. Yeah. I mean, if you have any doubts, please speak.
Okay, thank you.
Yeah.
Appreciate it. Thank you for your talk. And I have one more question. So you showed us a really nice tool how you can alert the users and, well, developers as for the issues which can happen within the cluster. But are you informed about some tools or maybe plugins which allow to restrict such actions, so to prevent them from happening?
There are some other alternative tools. Like, I mean, prevention, you can definitely prevent in your own way according to whatever, maybe set up some kind of restrictions in your applications, or set up some kind of strict RBAC in your clusters or service accounts and this kind of stuff. But there are other tools. I haven't used many of them. Maybe there's one Tetragon from Isovalent. I haven't used it, but there are some other tools basically which actually blocks those processes that have causing any security vulnerability to your application. Falco doesn't do that. Falco just alerts you, but you can have your own preventive measures, right, to stop that, to block that, maybe set up more restrictions in your application to avoid that. But if you are asking me any specific one, I think right now it's not coming in my mind. But we can talk about it later, and we can discuss further about it, like how we can do it. Yeah.
Yeah, when I see the alerting, I'm a little bit scared of alert fatigue, because when the alerts are flowing in a high rate, somebody has to look at them, somebody has to bring them into context and work them away. Isn't this the problem, that you have then to maintain another person which just looks at the alerts and works them away?
I work as a site reliability engineer, and we have like let's just talk like basic, and we have monitors, and the monitors gets alerted, and you get the noise, and get alerts and all of that. So you're gonna get the alerts, but as an engineer, you want to decide that what alerts you want to receive and what not, right? Because if you don't set the threshold, the alerts can be a bit noisy, and when something is a bit noisy, you avoid the most critical ones, like, I'm getting alerts every time, okay, just ignore it and all. So, and it can basically cause you to avoid and neglect the most critical one, right? So that's why you have the option in the rules that what are the rules like you want to get alert, and what are the warnings, and what are the info. And I think the purpose of this tool is to get alerted so that you can take preventive measures. Like some of the clusters, like if someone is running the pod in your cluster, and for crypto mining or anything, it uses a lot of resources or CPU and memory. You don't want to avoid that alert. You want to be in a zone. So, but you don't have to be look at always your Falco sidekick QI or any other. According to your requirements, you can set up, get those alerts with the Ops Genie, with the PagerDuty, or with the Slack, maybe just the warning level alerts you want to get, and not the info. So you have so much flexibility to customize those alerts, what you want to receive and where you want to receive. And that's how you can basically reduce the overload and the noise, and maybe more focused on the more critical ones. Yeah. Does it answer your question? Thank you. Okay.
One more question in the back.
Can Falco give me some recommendation based on the applied rules? So if I apply some rules, I can plug one hole and open a whole new bottle of hell. So can it somehow analyze the applied rules and suggest me some other ones I need to apply as best practices?
Mm-hmm. Well, the default rules comes with the best practices, right? And if something you don't want, you disable it. But Falco it's an open source tool, and it has in the GitHub, big rules files, and a lot of the information is already there on the internet. So you can definitely have the good guidelines. And the security guidelines, it's a security engineer. As an engineer, you can decide on your own and look on the internet and basic security practices. But Falco does it and enables you to apply them, right? But there is a lot of information that is already there on GitHub and also with the Falco default files, which gives you a great idea that what you basically want to, like for example, if you are using GCP, not AWS, and there are rules with the AWS, you can just disable them and enable them for GCP, and maybe Azure, you can write your own rules or something like that. So, that's, I think, your call, but there are guidelines on the GitHub, on the documentation, it's a great, and as Falco plugins also enables you for the different event sources. So, yeah. Does it answer your question?
Yes, thank you.
Okay.
All right, so I think that brings us to the coffee break. Okay, one more quick one. Just a second, need to catch the mic.
Yeah, hi. Thank you for the presentation. Just curious though, does Falco integrate also with open telemetry where we...
Open telemetry?
As in when we put the logs from AWS or any other cloud.
Yes.
So we can also get alerts from there as well.
Yes, definitely. And you can even store your alerts and everything in the S3 storage as well. You can get the open telemetry, and each and every tool, there are so many tools that are available. I can maybe just quickly. Yeah, it happens. I think there is some musical band with Falco or something which always shows me. You have to write Falco CNCF. You have to tell that. Okay, so the output channels. These are the output channels, formatting, forwarding alerts. Yes. So these are the basically list, chat, system, metrics, observability, Prometheus, and alerting. For logs, for object storage, AWS S3, serverless, AWS Lambda, you can get those alerts from there. Messaging queues, AWS SQS, and a lot. I didn't even have used all the tools, but there are so many. Email, even you get the email. List is huge. You can definitely get the alert. There's no doubt. Yeah.